Can you all see my screen?
Yes, it's visible. Can you please close this Google Meet window?
Oh, yes. Sorry.
Yeah. Okay.
All right. So yeah, as I said before, my name's Dylan, and this is an AI clinical trajectory model. So a little bit of background before we get started is I've been in the ER the past 2 months, over 100 hours. And in that time, a problem that I've seen, which is kind of what I developed this AI around, is that a lot of patients come in with complications that are extremely time sensitive. And a lot of times it's kind of too late when a doctor is able to treat a patient for a certain thing. So sepsis is the one disease that I kind of modeled my MVP around. And basically what that is in a nutshell is it is an infection that spreads throughout your body. It gets into your bloodstream. And so it is one of the leading causes of in-hospital death, actually. So it moves really fast. Every hour of delayed treatment increases the risk of dying, and every couple minutes of delayed treatment increase the risk of long-term complications from it. And so what the medical field uses today is something called QSOFA and NEWS2. Those are just acronyms, and basically what they are is they're checklists of like what are the vitals supposed to look like in a person that has a certain complication. So oftentimes when the doctors use this and they're alerted of a patient's vitals, it's too late. They've already crossed the danger line, and they will have complications for the rest of their life. So we'll go to the next slide here. Why this matters is this has been my passion for a very long time, since I was young. Emergency medicine has. And so this system could have a huge impact on the world of emergency medicine and reduce mortality in people with sepsis and other diseases too. So this model kind of looks at the trend and the data. So how is somebody's vitals and labs looking over time, not just a single snapshot like the current system uses. So it's also extremely measurable. So you can use real hospital data and I can test this model against real patient data, like real people with real vitals and a real case of sepsis. So the solution uses two models, a random forest machine learning model and an encoder-only transformer that I custom built. But I don't have enough data for the transformer to be fully operational yet. So the MVP kind of just uses the random forest model. Like I said before, it predicts that somebody is going to start dying 2 hours before it actually starts, which is an extreme jump from the normal right now. So my system, again, like I said, reads trends. That's what makes this, I feel like, a real serious possibility for industrial application. And so it reads the trends. It's not just a snapshot. Again, it predicts 2 hours ahead, which is a huge gap from the modern day standard. And it's truly calibrated. So when it says 72%, like you'll see in a second, it means 72%. So here are the results. So my model against the clinical standard, you can see kind of on the left, that's like the accuracy, and the main thing on the right is the lead time. It is able to predict, again, 2 hours before the clinical standard and these kinds of things. So we'll move on to a live demonstration of my app. So here's the app. Right here, you can see the risk trajectory. You have all these patients that were synthetically generated. So these are synthetically generated vitals and labs right here. So these are all things that doctors take on a person to figure out what's going on. So right here, you can see where the model is predicting. So it jumps from 0 to 91 based off of these risk drivers here on the right. So it used these things to predict that somebody is going to start deteriorating from sepsis and start dying. And so right here, you can see when they actually started dying. So it was at 273 minutes, and it predicted it at 110, which is 160 minutes before they actually started dying, which is a huge jump from the clinical standard. So right here, like you saw before, is the model benchmark that was on the slides. The only real thing that matters right here is the lead in minutes. So you have 188 minutes before somebody starts dying that it predicts that they are going to, right here, versus the clinical standard, which is right here. It is 57 minutes. So huge jump. It makes a real difference in how a patient recovers from something like sepsis. So my team and my contributions. So obviously, I built the system from the pipeline to the models to the dashboard, and then Gurong, my mentor, he helped me through each concept from the basics of kind of what a machine learning model looks like, and then to advanced transformer concepts like how to build a transformer model, a deep learning model like that. So the impact and future scope. The impact is that it has the potential to save people's lives and prevent long-term complications from having something like sepsis. And it is the numbers that I showed are extremely trustworthy. The model's not looking into the future at future labels. It's calibrated. So the roadmap for the future is going to look like the clinical trajectory transformer is going to be able to turn all types of hospital data, because each hospital kind of has its own data stream, like the way they organize the data that comes in from a patient. And so it'll be able to turn that all into one simple stream of data that the model is able to understand. And then it'll be able to train across hospitals in different regions in the future. The problem right now is that I'm not able to access research level data because of HIPAA laws. So real data will take time to be able to get and train the model on. And then the system will able, or the models will be able to do this with more complications than just sepsis in the future. So DKA, which is extremely deadly. I saw that 2 days ago. Somebody came into the ER with that, and by the time that we figured out that it was DKA, it was a little bit too late, and so he had to go to the ICU, and he made it. And respiratory failure, things like this that are just extremely dangerous. And so, final thing, the limitations. It's not clinically valid yet. So the synthetic data that I made for the model to train on, it's realistic, but it doesn't fully reflect how a real patient's data comes in. The real data is limited and behind research restrictions. The reduced SOFA, basically all that means is that it's not able to see the full scope of everything that's going on with the patient quite yet. And it's also not able to see all the drugs that are given to a patient for them to be able to survive. So right now, the machine learning model, as I said before, beats the transformer model right now just because of the limited amount of data. But in the future, with more data, the transformer model should be able to beat the machine learning model. That's the goal. But it's something that I can only do with research level data. Um, Thank y'all for listening. Do y'all have any questions about anything that I said?
Yeah. First, you can stop presenting.
Okay.
Yeah. Uh, Firstly, see, the idea is pretty unique. I can see the inclination that you have towards like all the. I think so. You were in trauma. What's that called? Trauma center or the
Yeah.
trauma part?
Yeah.
Yeah, so that inclination, I can see that because your the part that you chose, right? It's very specific, sepsis, right? So did
Right.
you like on a day-to-day basis, like in a week or so, how many patients actually suffer from this kind of disease, and how effective your product is in order to reduce that kind of cases?
So on a day-to-day basis, as far as I've seen when I'm in the ER, there's around probably one or two patients that come in that have sepsis along with other things. And my model, as far as typically when they come in, the doctor takes a while to be able to analyze the data that is given to them, and so um, this type of model that I've created is sort of an alert system so that doctors are able to understand, hey, this person is going to start deteriorating, and they can give them treatment as soon as possible. So it will increase the survival rate of sepsis and prevent long-term complication very effectively in the future.
Okay, got it, got it. Yeah. So, your model is able to detect that a person is about to die before like 2 hours, right? What's the
Mhm.
current one? I think so. You showed it, but can you please mention that again?
It is 60 minutes or around 57 minutes is the typical now. And again, every hour really counts. And when I say 2 hours, I mean 2 hours before the clinical standards. So it's around 2 to 3 hours before somebody's about to die, which is a huge jump.
Okay, got it. Uh, that's impressive. I mean, yeah, no, like, what's the data like? What did you use in order to like predict that a person might die because of sepsis?
So that is based off of vitals. So when your blood pressure gets too low, your heart rate gets too fast, or your labs, such as your lactate, gets too high, somebody will start dying. Your organs will start failing, things like that. And so the model uses those kinds of things to detect that somebody is on a trend towards dying.
Okay, got it. See, there were a lot of numbers. You had some kind of comparison as well, right? How much
Yes.
effective your product is. Then maybe you can include some other numbers, as in like how effective your product can be, as in terms of like how many patients might who are actually dying because of this kind of infection, and how much overloaded the doctors are because of the workload, or maybe not able to give the right kind of diagnosis at the in such an emergency situation. So that kind of numbers or maybe percentage that you can include if they use a product, uh how many or the percentage of people that can be saved. So you can do that as well.
Okay.
And other than that, what do you think can be the other features that can be developed in your product?
I think the other features right now are just more and more types of data. So you have, all of the labs, it doesn't currently have all of that. And then all of the vitals, it doesn't currently have everything. Right now, it has everything that pertains to sepsis. So all the things that are affected by sepsis. But it doesn't have the full scope. So I think that's something that could be implemented in the future. And I think also something that could be implemented in the future is more diseases and complications that come into the ER, such as, like I gave the example of DKA and respiratory failure, which are things that are just extremely deadly that come in. And so things like that can be implemented in the future.
Okay. Currently, I think so. It's using synthetic data, right? So
Yes.
how going to like integrate the data that's there in the hospital with your product?
So before I integrate it into the hospital, I have to make sure it is clinically valid, which implies that I have to train my model on real data. Right now, the data that I have access to is very limited because there's laws against accessing people's information as far as that goes. So those are all behind research. You have to get research permission to get that type of data, and so that'll be something that has to be done in the future. But yeah.
Got it. Got it. Um, are you planning to include like, okay, this is an emergency situation, and these are like the steps that a doctor can take to calm down the situation or reduce the amount of infection that a person can have?
So I could, but in my experience, emergency medicine doctors and trauma doctors are extremely versed in how to treat every single disease. So I don't think that is as much important as it is detecting it and alerting the doctor that this is something that is going to happen.